Hello friends, welcome back. So we will see one more problem when they are giving indirect limits. Okay, so look at the problem, second one. Evaluate double integral of x square plus y square into dx dy in the positive quadrant of x plus y is less than or equals to 1. So let's write the given integral. So given I is equals to double integral of r, the function is x square plus y square into dx dy. So let's identify the diagram here because we need a bounded region, right? So here x plus y is less than or equals to 1. We know that x plus y represents a straight line. So if you draw its diagram, so this is your x axis and y axis. X plus y equals to 1 means on x axis you make a point 1 and on y axis 0.1 approximately. If you join these two, so the name of this line is x plus y is less than or equals to 1. Means what is your bounded region? So your bounded region, if you identify the intersections 0, point A, point B. So this is your bounded region. So on this bounded region we need to choose the limits of x and y because the given variables are x and y. Let us choose the limits of x and y. So to choose the limits, so you are following the previous procedure. If you choose x axis on x limits on x axis, to choose y limits you are writing a vertical line which is parallel to y axis. So now let us see the variation of x on x axis. So x starting value at the origin is 0 and x ending value is 1. Therefore directly let us choose the x limits from 0 to 1 on x axis. Then to write y limits you draw a vertical line in the closed region, vertical strip. Okay, so you point, we name it as point P and point Q. Point P is on x axis. So on x axis what is your y value? Y value is 0. So you always remember on x axis your y value is 0 and on y axis your x value will be 0. Here point P is touching at x axis, therefore your y value is 0. So 0 acts as a lower limit of y. So at point Q you take expression for y. So at point P, point Q is on straight line. Okay, so straight line name is x plus y equals to 1. So x plus y equals to 1 is the straight line name. So here if you take expression for y, y is equals to 1 minus x. So therefore 1 minus x acts as a upper limit of x. Now you got the limits of x and y. So use these limits for integration. I is equals to, so your constant limits are from 0 to 1. Second integral takes the limit 0 to 1 minus x into x square plus y square into, so what is your order of integration? First you are integrating with respect to x or y. So it will be depending on your innermost integral. So your second integral is 0 to 1 minus x. Means these are the limits of y and 0 to 1 are the limits of x. Therefore first we are going to integrate with respect to y, then with respect to x. Therefore you write dy into dx. So let me integrate. I is equals to integral 0 to 1. So integration with respect to y means x square is constant. So 1 into dy, integration is y square sorry. So integration of 1 to dy is y plus y square integration gives y cube by 3. The limits are from 0 to 1 minus x into dx. So if you simplify this, integral 0 to 1, x square is constant. In place of y, you are using upper limit 1 minus x. It means 1 minus x. In place of y, if you put lower limit 0, it will be 0. So I am skipping this step. Plus 1 by 3 is constant in second term. In place of y cube, if we use upper limit 1 minus x, you are getting 1 minus x whole cube. For lower limit, it will be 0 into dx. So if you simplify this, integral 0 to 1, so x square into 1 gives x square minus x square into x gives x cube plus 1 by 3 into 1 minus x whole power 3 into dx. Now we need to integrate this expression with respect to x. So this equals to integral 0 to 1 x square integration with respect to x gives x cube by 3 minus x cube integration with respect to x gives x power 4 by 4 plus 1 by 3 into 1 minus x power 1 minus x whole power 3 integration gives 1 minus x whole power 4 by 4 into, here the x is multiplied by the constant term minus 1, therefore in denominator you are getting minus 1. Limits are from 0 to 1. So then wherever x is there, in place of x, if we use upper limit 1 and lower limit 0, so you are going to get the terms. So in place of x you are putting 1, therefore so 1, your first term x cube by 3 becomes 1 by 3, for lower limit it is 0, minus second term is x power 4 by 4. So when you use upper limit 1, you are getting 1 by 4, for lower limit it is 0. Then your next term, so 3 4 ja 12. So if you simplify this, so 3 4 ja 12, minus sign is there na, minus 1 by 12 into 1 minus x power 4. So in place of x, if we use upper limit, so you are going to get 1 minus 1 0, and if we use lower limit, you are getting minus of 1 minus 0. Okay, then if you simplify this, finally you are getting 1 by 3 minus 1 by 4. So minus into minus becomes plus 1 by 12. So if you simplify this, your final answer is I is equals to 1 by 6 is the integral value. Okay, so you try to work out these kind of problems. Now in the triple integral also they may ask similar kind of problems, means they are not giving limits directly. So if you look at the third problem, evaluate triple integral of x plus y plus z into dx plus dy into dy dz, where v is bounded by the plane x plus y plus z equals to a, where a is greater than 0. Here also the identification of variables takes a very important role. So first you need to identify the variables. So given variables are x, y, z, means you need to identify the 3 limits. Okay, so how to identify? What is the hint they are given here? V is bounded by the plane x plus y plus z equals to a. So let us write the given integral, triple integral of v value plus x plus y plus z is the given function into dx dy dz. To identify the limits, you take the given expression, given x plus y plus z is equals to a. Here you take the expression for z directly. So if you write expression for z, so z is equals to a minus x minus y. So z equals to a minus x minus y acts as a z upper limit. Then in next step, take it as equation 1. So x plus y plus z equals to a, you take it as equation star. So in star put z equals to 0. If you put z equals to 0, what you get in equation star? X plus y equals to a, because z is 0. Then from this expression you take expression for y. So y equals to a minus x. So take it as equation 2. So equation 2 acts as an upper limit of y. Now again put y equals to 0 in equation star, y equals to 0 as well as z equals to 0 in equation star, becomes x equals to a. So x equals to a acts as a upper limit of a. Therefore your limits, if you rewrite the limits here, limits of x are, so always the initial values. So initial lower limit of x, y, z you consider from the origin. So at origin your x starting value is 0, 0 to here you got expression for a, x variation from 0 to a, y is from again 0 to, so your y expression from equation 2 is a minus x. Then limits of z are 0 to, from equation 1, a minus x minus y. So you choose the limits of x, y, z and integrate as usual. So first you are integrating with respect to z, then with respect to y, then with respect to x. So this is the procedure of evaluation when they are giving indirect limits. Okay, thank you for watching the video.